Functional analysis 2. Definition. An algebra is a linear space A over K whose vector can be multiplied in such a way. This is associative law, distributive property, and alpha of xy is equal to in the bracket alpha x into y is equal to x into alpha y for every xy belongs to A and for every alpha belongs to field K. If K is real, then if field is real, then A is called real algebra, and if field is complex, then A is called complex algebra. A Banach algebra is called commutative algebra if x into y is equal to y into x for every xy belongs to A. A Banach algebra is called an algebra with identity 1 if 1 belongs to A and 1 into x is equal to x into 1 is equal to x for every x belongs to A. First condition 1 belongs to A and 1 into x is equal to x into 1 is equal to x for every x belongs to A. A Banach algebra is a complex Banach space which is also an algebra with identity 1 in which we have norm xy is less than or equal to norm x, norm y and norm 1 is equal to 1. An element x belongs to A where A is Banach algebra is said to be regular if it has an inverse in A. The set of all regular elements in A is denoted by G and the complement of G is denoted by S. That is S is the set of all singular element or non-regular elements. Lemma. Multiplication is jointly continuous. That means xn tends to x and yn tends to y in Banach algebra A. Then xn into yn tends to xy. Proof. Let me take norm xn yn minus xy is equal to we add xn into y minus xn into y. So we get xn common into yn minus y plus y common xn minus x. If norm xy using this norm xy is less than or equal to norm x into norm y, so is less than or equal to norm xn into yn minus y plus norm y into xn minus x is less than or equal to norm xn into norm yn minus y plus norm y into norm xn minus x. Now sequence xn is bounded, so norm xn is less than or equal to positive integer m. Now sequence xn is bounded, so norm xn is less than m for some m greater than or equal to 0, and yn tends to y as n tends to infinite, as well as xn tends to x as n tends to infinite. So yn minus y tends to 0 and xn minus x tends to 0 as n tends to infinite. So this tends to 0 and this tends to 0, and norm xn is equal to m. Norm xn is less than or equal to m. So we get less than or equal to m into 0 plus 0 into norm y tends to 0 as n tends to infinite. So this tends to 0 as n tends to infinite. So xn into yn minus xy tends to 0 as n tends to infinite. So xn into yn tends to 0, xn into yn tends to xy as n tends to infinite. So we can say that multiplication is jointly continuous. Definition: subalgebra: a non-empty set B of A is said to be subalgebra of A if B itself is an algebra under the same operation of A, that is addition, scalar multiplication and multiplication. Example of subalgebra: first, C is an algebra over C itself, R is an algebra over R is a subalgebra over C, and fourth, let a non-empty X and let A is equal to F, where F from X to K is a function, then A is an algebra. Thank you.